Okay, today the first demonstration that I'm going to look at is called the Moving Man. It's available from PHET, which is a Colorado college. Um, right now it's running uh, something that comes up a lot in this video, in this demonstration. It sometimes doesn't quite work. Right now, there's two things on it. We've got the introduction. Um, it's not as much here available. You can set the velocity of the guy and he runs over there until he hits a wall. I guess I can remove the wall. Not sure what happens then. Boom. Oh, he just keeps going. Okay. Or I can leave the wall there and he stops at it. Acceleration, I can make him start running that way. And he accelerates and accelerates and it shows the velocity vector there. And you can also show the acceleration vector until he hits the wall and stops. Um, so then on the other side of here, you got charts. I have something in there already that says sine 1.57 times t. I'll set it to 10 times that so that we get, this is x of t equals 10 times sine of pi over 4t. I don't know for sure whether it will start running. Okay, yeah, it started running. Um, but anyway, he should go up and turn around if that is programmed right. So that he'll come up to a peak and then come down to 0, except he's gonna narrowly miss the wall because the amplitude is 10 and then he comes down. So it runs kind of slowly, but the position there should have been found under the special features expression evaluator. So let's see if we can get him to run. We'll set up some starting positions for him. I'm going to clear everything. I'm going to set him back here at -10. I'm going to set his initial velocity to the right, maybe 6, and his acceleration to be -1. So it'll be accelerating towards, let me type in the numbers here. So -1 for his acceleration, +6 for his velocity, and position -10, and see what this looks like. He should be accelerating to the left. He starts out moving to the right, and so we'll get an upside down U shape for his distance, or for his position, and the velocity will continue straight downward. I'm gonna pause the video and, well, yeah, I guess I can let you fast forward the video if you want to go through it a little faster. Yeah, so he's slowing down. He's going to come up to a peak up there somewhere, unless he actually hits the wall. I don't know if he'll hit the wall or not. But oh, I can't bear it. I can't bear to watch. He's still going to the right, and as soon as that turns negative, or as soon as this starts sloping down, we know he's not going to hit the wall. Okay, he's standing up. He's standing forward, so he stopped and turned around. Okay, so that's essentially how this works. I can do one other thing, and that's come up here to Special Features and Expression Evaluator. And sometimes that comes up, sometimes it doesn't. I'll pause it and see if the Expression Evaluator comes up. Still didn't. So what do you need to do when it doesn't come up? I would just go up here to the HTML and hit enter, or you can do Control R to refresh. Then it takes a little bit of time to reload. Oh, by the way, the first time you load it, it takes quite a while. So hopefully that's not too big of an issue for everybody. Moving Man is starting up. Okay, once you've got everything loaded up, go over to Charts, and then click on Special Features and Expression Evaluator, and this thing comes up, and this is the problem. It's kind of buggy. It's already got this formula 7 times sine t plus 2. If the 7 is how the 7 here is the amplitude of the position. So if I have a 7 in there, it's going to go up to 7 and then down to -7 if I put a sine function in here. Now what should I put in the sine function? Usually it's 2 pi times the frequency. What do I want the frequency to be? If I want it to be a nice smooth curve, what I used before was a frequency of 1/4 of a second. That made the wave go up and then down. Okay, up and then down at 2 seconds and back up again at 4 seconds. I could decide I want the curve to go up and down and up in 2 seconds, and that would be pi over 2, or 2 pi over 2. So that would just be 3.14 times t. Don't forget your asterisk sign in there to represent multiplication. I'm going to hit enter. I don't know if anything happens then, but I hit enter and then I hit play, and hopefully that works. So he's moving, now he's moving in a sinusoidal motion. And you can see how when the position is increasing, the velocity is also increasing. When the position is decreasing, the velocity is negative. And so these, you'll be able to see it on the next line better, because right here it was a sudden jump, I think. But this is essentially the sine function, and then the derivative of the sine is cosine, and the derivative of cosine is negative sine. So sine, cosine, negative sine, and that's how that goes. Okay, while I had the video pause, I went ahead and reloaded so that I could enter another expression here. So let's think just a typical acceleration is 1/2 at squared. Let's give it let's type in like 10t squared plus, and then we'll give it a initial positive velocity. No, Let's give it a negative acceleration, so it's going down, a positive velocity, and a small position, like over at the -10, -10. And see what happens if I type that in. So, and yeah, we'll do that, see what happens. Okay, it looks like it didn't like that. So I had to restart it again. Then I'll go over to charts, go over to special features. This time I'm going to try it a little bit differently. Delete all that out. -10 times t plus 20 times t minus 10, no, plus, yeah, minus 10, because I want it to start out over here on the left. Okay, and then enter. So this time I did t times t instead of t squared. There, that worked. It didn't like the t squared, but it'll take t times t. It's kind of buggy though. It doesn't always, it gets an error in that in that expression. It gets an error in that expression evaluator, and then it won't run. Okay. All right. That's as much as I'll say about this demonstration for now. We'll see if I can see if I have an assignment for it.